So energy and work. We need to just add to our list of formulae some other formulae now to do with energy and work. And again, we're going to think of the linear formulae and also the angular equivalents. Some of them I'm sure you'll be familiar with. For example, the kinetic energy of a moving object given by half mv squared. So what do you think the angular equivalent would be? Instead of mass, moment of inertia, and omega squared, the angular velocity. So something moving it with an angular velocity omega, we could work out what the kinetic energy is using that formula. Particularly for linear motion and to do with an object's position. So here we have an object, a height h above an arbitrary 0. So we measure this height. We say something has energy just because of its position, stored energy, and if we were to release that object or let it fall, then that energy would be converted to kinetic energy. And so there's a formula that will tell us what that potential stored energy is in an object due to its position above this 0 point. Can you remember what that formula is? You don't? GPH, no. Maybe so similar, yeah. M mass, G gravity, H. Mass times gravity, what's that another thing for? Weight, right. So if I multiply something's weight, i.e. the force it's exerting, by the distance, then I get the potential energy. And another way of thinking about that, force times distance is work. So that gives us another formula. Work, force times distance. Hopefully a formula familiar with, and something we talked about this morning, didn't we? That graph plotting force against extension. The area under the graph is the work done. No angular equivalent for potential energy, but there is for work. And so what do you think that would be? So the force, because it's now a turning force, we call it a torque, and instead of distance we measure theta, yes, the angle. So those are three extra formulae that we're going to use. And we're going to look at the relationship between them, between the work done and the potential energy, kinetic energy. We talked about things falling. So here's an object falling, and we can talk about that potential energy at the top being converted to kinetic energy at the bottom. So energy can be converted from one form to another. And we can also talk about doing some work on something to make something speed up, and that would then be converted to kinetic energy. So there's a relationship between the work done and the energy stored or expended in a situation. And we're going to be looking at some examples of how they work, how it all goes together, combined with the equations of motion that we looked at last week. So that's our little palette of formula that we're now going to use to try and solve some problems.